Hey, how's it going? It's John from the Machine Shop. Got a bit of a weird unboxing type thing today. So my mother-in-law, she used to own, or her father created his own electronics business, and my mother-in-law used to run it, and she's stopped doing it now. And she said, "Well, I've got all this stuff left over. Do you want it?" And I was like, "Yeah, great." So the other day it was all left in my hallway, so I brought it up here. I haven't looked at any of this stuff yet, but she's given me loads of tubes, loads of tubes with what looks like ICs in them. Loads of them. There's loads of bags here, and then this thing's full of. And there's a tray of bits in here, and so yeah, we're gonna have a look through each one. I can already see some of them are just like resistors and stuff, but some of them look a little bit more cooler. There's loads of ICs and stuff in here, so I'll go through each one and see what they do. Alright, so let me just have an overview of what we've got here. I mean, there's loads of tubes and stuff with all sorts of, just looks like loads of different ICs, so we'll come on to that. And the drawers, I mean, a lot of these, like it just says 4K7, so that'll be a 4.7 kilo ohm resistor. Yeah, there you go. I'll go through what all the colours mean. And there just seems to be lots and lots of those. 2.2 meg ohm, 220 ohm, 15K, 1 meg, 5.6. You can see all these R1, R2, R10 and R18. That's where the PCB that she was using, the PCB had like a screen print on it. So where it says R12, she knew where she had to put one of those because it said R12 on there. What else we got? There's more in there. These are capacitors. So you see how it's got an F? That's farads. So that's 0.022 microfarads. So little through-hole capacitors there. Some more there. Yeah. Oh, IC sockets. There you are. So they're little tiny sockets that that's what you would solder up. That you'd solder that bit onto the board, and then your IC would sit inside of that. Protects the legs of the IC, and it means it makes it easier to like sort of take off. We've got a load of diodes in there. We've got this over here. Oh, they're funky things. What are they? Capacitors of some description. Nice small capacitors. Nice. Yeah, what's in? Oh, some ICs. Go through what they all are. More there. Oh, resistor networks. Now I think that one's also a resistor network, a 1K, but it's in a dual inline package, so check that out. Some more. Awesome. What was a sticker there from Farnell? That says that it is a MOSFET. Okay, we'll check out and see which one that is. There's some more ones there. Cool. What we got down here? Jumpers. Also random capacitors in there. Okay, yeah, jumpers and things. What's that one? DC to DC converter. Ooh. Okay, I'll open that up. See what's in that. Connectors. Oh yeah, some more of those IC headers. Awesome. Some connectors. Again, through hole. What are we looking at? 15 pin. 1, 2, 3, 4, 5, 6, 7, and then it'll be 8 along top. Yeah, 15 pin. 15 pin D-type connector. Nice. Oh yeah, look at this. Jackpot. We got a pair of strippers. Nice bit of action on there. Now yoink. So it sort of grips the wire, and then those two metal teeth pull the insulation off the wire, and then they let go of the wire, and then it all goes back. And then that little red bit, that allows you to set how much you strip off. What else we got now? Solder suckers. Boom. Cool. Oh, another one. Whee! So therefore, like when you made a slight mistake, what you can do is you can get the solder so that it goes all wet again, and then you can put the solder sucker on the solder bob and go boom and suck the solder into the solder sucker. So cool. What else in here? Lots of remnants of cuttings and stuff. soldering iron tip. A bit of solder braid. So again, for rework, you can use that as a. I'll try and get it so you can see it. You can use that so that you put the you put that on the solder ball, and then that would wick the solder up this, because the solder will go to wherever the highest heat is, because this is a copper wick. This would get hotter first, so it gets sucked up here and away from the solder joint that you're trying to do. Now what else we got? Whatever that is. Bit of solder. Nice. Slightly thinner. Cool. Yeah, so a few free tools. Nice. Easy peasy. Better count that back in. Right. Alright. Well, let's check out all these. Oh yeah, what was up here? In this tray. Buttons. Does it say what they are? No, it just says where they're from. Where they are. If anyone wants to read the part numbers and go get the data sheets and all that, they look like little buttons. Cool. Okay, so yeah, most of the things that we've gone through on here, most of them are just resistors. So we've got some nice diodes here. These are 1N4148 diodes. They are 1 amp, 200 volts, standard diodes, I suppose. Well, there's a little sticker there from Farnell. Yeah, it's literally called diode standard 1 amp, 200 volt. There you go. There's lots of different types. They all look different. You see that tray there? See if I can get it to not zoom on my face. No, focus on my face. They're all different. They all look. There's some little tiny ones down here and some slightly bigger ones up here. So I can't imagine they're all going to be that style. Oh yeah, here we go. What's this one? This says DG411. All right, let's take this out and have a look. See what we got. DG411. It is a precision monolithic quad SPST CMOS analog switch. Okay. And we've got the dual inline package, which is this one here. So we are looking at an input, and then you've got literally like a switch arrangement here. Okay, that's interesting. Okay, so basically what it allows you to do is, it would say you can have an analog signal being turned on and off by a digital signal. If you think of it like a relay, where you've got a electromagnet and a switch, that allows you to switch high current and stuff, but probably not as good at doing probably like audio signals or anything like that. So I can imagine this is what this is specifically designed to do, is to do those analog signals. Cool. All right, what else we got? So we've got a CD4075BE. Let's check that out. Okie dokie. Oh, it's an OR gate. Oh, very cool. For those of you who don't know what an OR gate is, I'll be doing an extra video coming up soon, all about logic gates. So this one is an OR gate, so remember that for that episode. So this is the CD4075BE. So the 4075BE there is a triple input OR gate. Feel free, if you've got any questions about like any of these things, leave a comment and go, like, what is it, or what does it mean when this is this? You know, if you've got similar sort of things, I'll quite happily try and answer your questions. You know, if you see anything as I'm scrolling through this in the datasheet, if there's anything on here you're thinking, what does it mean by the input voltage range or the device dissipation per output transistor, don't ask me that one. Alright, let me move along. This is a CD4002BE. Now, if I go on the fact that the previous one was a CD, what was it, 4075, this is a 4002, a NOR gate. So anything special on this one? Let's check out the bits and pieces that we looked at before. So we've got the 4002, which is a dual 4 input. So here's the little diagram down here. So it is a 4002 is a dual. So this one here, look, 4002. Let me see if I can zoom in on this. There we go. So we've got 2, 3, 4, and 5 are the inputs, and the output is pin 1. And then there's another one in there as well. For those of you who know your gates, then you know what I'm talking about. For those of you who don't, we're going to check out that video soon. Right, what else we got? It's a HEF 4538 BP. Alright. It is a dual precision monostable multi-vibrator. The HEF 4538B is a dual retriggerable, resettable monostable multi-vibrator. Each multi-vibrator has an active low trigger. That's much better. Right, go on, moving on. Right, so what is a monostable multi-vibrator? So if I remember correctly, there's a really famous device which, if you do any electronic engineering, you'll understand exactly what it is, and that is the 555 timer. I'm going to look that up quick. 555 timer. And the 555 timer, here we go, is a data sheet from TI. What do they class that as? They class it as a timer. Of course they class that as a timer. So this can operate in bistable and monostable modes. I think it's very, very similar. Let's just quickly look up. So monostable multi-vibrator, there we go. A monostable multi-vibrator is an electronic circuit that generates an output pulse when triggered. A pulse of predefined duration is produced. The circuit then returns to a stable state and produces no more output until triggered again. Okay, so essentially when you give it a very quick pulse, it can then do a pulse of certain duration. So that's very interesting. So yeah, so essentially, oh, here goes a little, let's have a look at this. Ooh, look at this. Am I allowed to use websites in videos? Oh, you were going to Google it anyway, weren't you? So yeah, essentially what you've got is your input here, and then that can give you you can see how this has got like a trigger input, so it's like a very quick, like a blah. Then you've got a steady output. So that would actually be really useful as an input to like a microprocessor or a microcontroller device. So imagine you've got a frame that goes round in a circle, right? So this is where the code starts, goes all the way around and back again to the start. And at this point is when it tries to see if this has got any pulses on it. So it would go around like that, you'd get a pulse, and it wouldn't see it until here, and it would go, nope, no problems. Come round, pulse, you come around to here. Now maybe it goes round and it goes pulse, and it goes, oh yeah, triggered, okay, I've seen one. Whereas what this little device would let you do is you would be able to have that pulse, and it would go, it would come around and go pulse, and it would stay there, and you go, oh yeah, okay, there was a pulse in between that time frame. So very handy little device. This is, what's this one? So this says that they are MOSFETs, ZVN 2106As. So it was ZVN 2106, 2106A. You know when you get that feeling that something's listening and searching for you? I had no idea what that part number was. Yeah, all I had to do was put in ZVN and it finished off the whole part number for me. Somebody's listening. Right, let's have a look at this. So sure, this is a N-channel MOSFET. Okay. If you don't know what an N-channel MOSFET is, let me know in the comment section below, or a P-channel MOSFET or any MOSFET, and maybe I'll do a little quick intro on what a MOSFET is. Very cool little things. And I also know a few things about, like, if you wanted to use a MOSFET with something like a Raspberry Pi or something with an Arduino or anything else, what specific ones to go for so that they work with those. So yeah, let me know in the comment section if you want to see another one special on MOSFETs, and I'll do that for you. Let's have a look, see if there's anything special on here to do with this MOSFET. Okay, so it's got a 60 volt is the maximum voltage it will go to. RDS is 2 ohms. We've got a continuous amount of current that it can sink is 450 milliamp. I shouldn't say sink, because essentially what it does is imagine a MOSFET is like a switch. It's the amount of current that can go through that switch. A pulse drain current of 8 amps. That's great. Cool. Oh, not a lot on there. Alright, let's move along. What else we got? Okay, yeah, that's basically it. I mean, we've already been through the drawer of tools that are in the bottom. We've already been through the connectors. So let's have a look at some of these tubes. That's what we got. Oh, okay. So these are actually IC sockets, like these. Remember these from a minute ago? So these are 14 pin. Focus on the box, you. There we go. These are 14 pin IC sockets. And that's exactly what these are, I believe. Oh, these are 16 pin IC sockets. Go back on my face. Hello. So these are loads and loads and loads of IC sockets. 30 per tube, and we've got 1, 2, 3, 4, 5 tubes. That's 150? 150 IC sockets? All 16 pin? Lovely jubbly. Right. Okay, what else we got? Oh my god, there's more. Okay, so these are 14 way, so these are 14 pin, 34 per tube, and we've got 1, 2, 3, 4, 5, 6. 34 times 6? Hey Siri, what's 34 times 6?
34 times 6 is 204.
204, right. 204 14-way sockets. I hope these aren't all IC sockets, because that's going to get boring. No, I think some of these are definitely, what I'm going to do is just quickly, they're definitely ICs, they're definitely ICs, they're ICs, and ICs. Right, what we got? We have, going by the sticker, because I don't really want to take them out of their tube, it is an LM358. According to this, is a dual op-amp, operational amplifiers. They are, again, if you do any electronic stuff at college, op-amps, you'll be sick of them by the time you've done your electronics course. Again, if you want to know more about op-amps, let me know, I'll do a video on them. What else we got? JFETs. Oh, another type of op-amp. Right, this is what I mean. When you go to college, you'll be sick of op-amps because there's loads of different types. Again, these are 8-pin dual inline JFET op-amps, so a slightly different type. I'll cover that if I do a video. Oh, do you want to know the part number for you guys playing at home? It is a TL072. Oh, this one says CMOS, which means some sort of logic. And our partner on this one is a CD4071BE. Did we have that on the thing here? 4075 we had, 4002 and 4538. We have not yet had a 4071. Let's have a check. Let's have a little squidge of what this looks like. We have a 1, 2, 3, 4, 5, 6, 7. So it's a 14-pin device, dual inline, obviously. And just because they're easier to solder, and when you've got the little IC sockets, then it makes them easier to put on, take off. Well, what we got? So this is the CD4071BE. All right, let's go back over to the computer and let's check that out. It was the, I've forgotten already, my memory is awful, CD4071BE. Oh, actually, it looks like we've been on this datasheet before. It's another OR gate. So here, yeah, so we've got the 4075s. Here, this is a 4071, and the difference between the 4071 and the 4075, because I know you're dying to know, is that the 4075, the 4075 is a triple 3-input OR gate, and the 4071, of course, is a quad 2-input OR gate. So yeah, basically what that means is on the 75s there are 3 of them per IC. On the 71s there's 4 of them, but the 75s have 3 inputs. So if we come down to these diagrams here, you can see this on the 75 has got 3 inputs and 1 output, whereas, oh, can you see that behind my little face? Let me see if I can do something like that. Here we go, 3 inputs and 1 output, whereas up here on the 3071s is a 2 input and 1 output. Again, if you want to learn about logic, there's a video coming soon. I'll be mentioning all that in them. Got a feeling when it comes to logic gates, because there's loads of different types and different things, like different inputs and different packages and all that sort of stuff. I think what I might do is do separate videos. So I might do a series just on logic gates. So make sure you hit that subscribe button, hit the little bell icon so you know when that riveting video is coming your way. Right, what else we got? We have a comparator. A dual comparator. A dual 8-pin comparator IC. For those of you playing along at home, it is LM393NG is the part number. Let's have a quick squidge. Yep, sure enough. Just looks like any other IC. It is an 8-pin. It's like a train of them. Surely I can get this thing to focus. It's like a train of ICs. Right, what is a comparator, you're dying to know? Well, I'll give you 3 seconds to guess. Correct, a comparator compares. It has, let's grab the data sheet. Let's grab the data sheet and have a look. Okay, a low offset voltage dual amp comparator. So yeah, here we go. So here's our little pin connection diagram thing down here, down on this bit. So we've got 2 inputs and 1 output. And essentially what it does is it compares the difference between the 2 inputs, and if there is a big enough difference from the threshold, then the output goes high. Simple enough. If the difference goes the other way, then the output goes low. Simple enough. What's next? Oh, last bag, last present. Better be good. We have the description, right? Can you see the description? It's a really faded sticker, I'll give you that, but can you see that description at the top there? Just about. It says IC gate is what it says. IC gate. A gate integrated circuit. Right. Part number customer problem CD4. Oh. It's a CD4075. There we go. CD4075BE. Just loads of them. So there you go in the 4075 bucket. Cash your mind back, what was the 4075? It was the, I'm not going to look because, well, all I'm looking at in here is the comparator data sheet. So the 4075 was the 3 input and then try, so there was 3 per IC, 3 input OR gate. So yeah, cool, okay. Alright. Nice bit of stock to go into my Chinese Tupperware boxes and my little tiny boxes with me op amps on it. I think I'm going to need some bigger boxes considering, stop focusing on my face and focus on what I'm looking at. There we go, op amps box. And where's my, no, that's an OR gate. Is it an OR gate? It is an OR gate we're looking at, that not gate. There's my little bucket there of OR gates. So I think I'm going to need a better bucket to get that lot in there. So yeah. Excellent. Cool, well, thank you for joining me on this video. My name is John. You can find me on Facebook, Instagram and Twitter. And yeah, hit that subscribe button and let me know in the comment section below if you want to know any more detail about any of the stuff that we've looked at today. And I will see you in the next video. Bye!